Hello and welcome back to the channel. We're going to get back to the restoration on this Zenith radio, or Zenith or however you correctly pronounce the name. Actually, I looked it up and it is Zenith. So I stand corrected in my vernacular for always pronouncing things incorrectly. Such be the case, I guess. But anyways, if you're new to this channel, please consider subscribing if you enjoy the content that you have seen today. Also, please consider giving this video a thumbs up. As I mentioned in all my videos, I operate Having Fun Repairs as a business in the state of Oklahoma. If you want to know more about the business side and you got a device that you're needing to have repaired, no matter what it is, electronic device, see my link in the description to my Google site. It'll take you to my business page. And if you're just inclined to donate, you can do that as well. PayPal's in the description. But I want to get started back on this radio. At minimum, we're going to tackle replacing the cone of the speaker and restringing the tuner. I'd like to get into some other things, but those two things we'll start out with first. So without further ado, let's get into it. So I did find myself online 4-inch or 19.5 millimeter speaker cones to replace what is in here. Got them off of Amazon for $8.59 plus tax, shipping, or whatever. But I've never put a new cone on a speaker, so this is going to be first time for me. But I think I can work my way around this. So I'm primarily going to try to carefully remove this kind of cork material outer rim, and then see how we can remove the actual cone and get the new one in. Let's see how this goes, and hopefully I don't mess this up too much. It's been quite a bit of time. I think I'm okay to remove this weight off of here, although I should allow this glue at least 24 to 48 hours to fully cure before operating the radio. I'm going to now draw my attention to our tuner over here on the right. The diagram calls for the tuning game to be fully closed. You can already tell as well that our spring, which puts tension on the cord, is fully closed. There is no tension whatsoever on this dial cord. It also calls for 1.5 turns around our posts right down here. So not too sure exactly how I need to tackle this one. Do I trying to rest this on something without bending these wafers in here? I don't want that to occur, because that's going to affect our tuning. But not sure how to tackle this one. Do I want to cut the string on this side here and shorten it up to get tension, or do I want to chip away over here, put a new loop in, and draw tension all the way through the mechanism? I think that's the more appropriate method, probably the one I'm going to go with, but I imagine it's not going to be incredibly easy. I guess we'll find out. Everything turned out rather nicely. The glue that was used on this dowel string broke, basically caused the string itself to shatter at the end, break away. So just that little piece removed, and then making a new loop, it allowed me to tighten up the string just enough that we now have tension across this spring here, and it's working really well. I'm very pleased with that. Additionally, our speakers in, I think it turned out rather okay. My only concern is the fact that the outside of the speaker cone is beveled. Will that touch the chassis at all and muffle the speaker, or change the sound a bit? That's something I have to keep my eye on. Additionally, off camera, I decided to go ahead and touch up our antenna wire here, because it wasn't really soldered on well, and did a bit more cleaning inside of our tuner. And now I want to address these 3 resistors we have here, because they're dealing with our filter and our lines voltage, and so they get really hot, and as I mentioned, they're pretty baked. We have this brown, black, red, and then our tolerance band. This is a 1K ohm resistor. I believe it is a 1 watt resistor. We have a red, I think black, so potentially 22 ohm, probably quarter watt resistor or half watt resistor, so 1000 ohm, 22 ohm, and then we have a orange, white, black. I believe this is a 39 ohm resistor, maybe a 2 watt resistor. We'll verify that on the schematic. But what I want to do is record down what they what their current resistive measurement is at, and then I'm going to plug this in and let it get warmed up, and then recheck the resistance across each one of these resistors to see how much they drop, and that may be able to give us a good idea of whether or not we should replace these or not. Going back to the diagram, we're looking at 24, 23, and 22, and our parts breakdown has them listed as 1000 ohms, 1 watt resistor, brown, black, red. 22, that was 22. 23 is a 22 ohm half watt resistor, that was red, red, black. And 24, a 39 ohm 2 watt resistor, orange, white, black. So we see what their purpose is for here across our filter, surge limiter, and our line drop. Speaking of line drop, remember one of our tubes was swapped out? That was the 50L6 GT with a 35L6 GT. Well, the Sylvania diagram, here we go, did indicate to us that we can swap out the 50L6 GT with 35L6 GT. However, we need to be concerned about our heater voltage. So we'll be checking that as well. And we'll see what it is at under operation. Wonder what the heater voltage should be. We have it here. Here, cathode voltage 90 volts. So we're looking at pins 2 and pin 7. So we can check that as well. Okay, what do we got here?
An organization called the Mymatevince, which promotes Christian virtues among men. He's a pro-life activist in Philly on Wednesday. She's sidewalks councils at Planned Parenthoods in Philadelphia for 6 to 8 hours. According to Greg,
looking at 130, roughly 130. I'm gonna let that run for a while, see how hot they get. May have been looking at this incorrectly. I think I should be looking at this 35 volts sitting right here. We'll go to pin 2, see what we got. There's the key, so 1, 2 would be right here. We're at 26. 10 volts under. This is definitely one of those moments where I'm not too sure, because I'm unfamiliar with these type of radios if I'm looking at things the right way, but the heater voltage being lower than 35, I assume that's the nominal. The 90 that I was looking at earlier is probably the max, and it says right there on the screen maximum rating. So we're below that on pin 2. I might try to find an original tube to stick in there, because I don't want to mess around too much with the chassis to see if try to get that voltage up. What is what are my resistors looking at? Wow, up to about 180. That's cooking, in my opinion. I imagine the tubes can get that hot. 200 on that one, almost 190. This one seems to be staying around 150, 155. Yeah, I want to change a couple of these out to see what difference that makes. I don't recall what I said before. Most likely something stupid because I was talking on the fly instead of thinking about things. But as heat goes up, so should resistance. And of these resistors, see 39 normal room temperature was measuring 40.7 ohms. When heated up, its resistive value went up to 41.2. The 22 ohm resistor normally was at 23.9, so slightly high, and when heated up it jumped up even more to 24.5. And then our 1K ohm resistor, it actually went down. It went from 99.7 to 98.5. Why is that? This value went down. That's a bit odd to me. Somebody smarter is gonna have to let me know that one. Okay, I swapped out that 1K for a new one, 1 watt resistor. The 22 half watt swapped out for a 22 1 watt, then left the 39 ohm 2 watt resistor. Check to see what the temps are at now. Had this running for a little bit. This radio definitely needs a pretty big alignment. Needs to be realigned. Okay, so we're 160 on that 2 watt. That's down about 80 degrees Fahrenheit. It's going to be kind of hard to come over this way. Get a better angle on that other one. Saying 220. That's to be believed. Going up to 1 watt from that half watt resistor for the 22 ohm. I think previously it was like 190, 200 or something. Now we're at 224 on that 1K. That's up a little bit higher as well. I also cleaned up our wiring from previously to make it a little more tidy. I replaced that red wire with a green one, ran it all the way over to there so I can get it tucked away the way it was previously, and I replaced this white one that was sprung up over. So it's a little more tidier over in here now. What are we on our heater voltage with those resistors replaced? Let's see. One and two right here. Still around 26, maybe slightly higher. Added a second orange drop because these caps over here weren't this Sprague recommended part number. According to the IPB, made a suggestion for that. I want to see if there's any difference in quality and sound. It doesn't really appear to be much of anything. I am slightly more concerned about the temp of these replacement resistors I put in. Ultimately, I think I'm going to have to get this 35 L6 GT swapped out with a 50 L6 GT, because nothing was done in the radio according to the Sylvania Swaptronics tube swap guide. So I want to get that back to factory and get that guy swapped out. I'm also going to get some grommets for our tuner over here to get these replaced. They're in very poor condition. It might help out a bit. I spent a little more time just diagnosing some things on the back of this radio, trying to familiarize myself more with our tubes and our voltages while the system was powered up, you know, and working. And then over on the diagram, measured our voltages. Everything seemed to be pretty close, with the exception of a couple things here for our 50 L6 GT tube, which of course was swapped out with a 35 L6 GT, so maybe that's some of the differences. But on both heater pins, I was getting pin 2 85 and pin 7 36 volts, or around about that. And if you look back over here at this is a diagram for the 35 L6 GT. There it goes. You know, heater volt 35, so I mean 36 is just 1 volt higher than that, but your maximum with respect to the cathode is 90 volts. So I think you're fairly safe without you know, changing some resistors to create a better voltage divider to lower the voltage at all. I think you're fairly safe not having to modify the chassis with the 35L6 GTN. But regardless, I did get on eBay some 50L6 GTs. They haven't came in yet, and you know, checking the diagram over here, your heater voltage can be a lot greater, 50 volts. And then with respect to cathode, you're significantly higher as well. So, you know, since the system, and I've gone over this diagram multiple times, and just checked the orientation of the capacitors I put in and everything else, and it's wired up as it should be. Everything's in there as it should be. You know, minus the fact that you know, originally according to the diagram we had a 60 microfarad and a 20. What was on there when I bought it, along with the 50 L6 GT being swapped out, was a 50 and 30, but that's still, you know, 80 microfarads total. I think that's going to be relatively fine. Anyhow, so the one thing I did want to check is I came over here and started making our, you know, unpowered the system, making our resistance measurements. Again, going to each tube and measuring, and you know, because when I was tuning on the dial, right between stations, did you heard it a little bit ago? To me, it sounds like we've got a little some oscillation going on, and you know, if the capacitors are oriented the right way, that shouldn't be the issue, unless if it's occurring because this was swapped out. But I was kind of concerned with our resistors, taking this to our B negative line. Maybe that's creating some of that oscillation that we're seeing. And to be honest with you, show you something here. I'm connected between our B negative line and pin 7 of 12 BA6, and I'm supposed to be measuring 68 ohms. And if you look at the color code, that is a 68 ohm carbon resistor, carbon composite resistor. But yeah, I'm at 101, And if I were to take it directly across the leads, instead of measuring between here and there, it would still come out as 101. So that one's pretty far off. And I think this one down here was pretty far off as well. Supposed to be 470. I'm at 450. This one's supposed to be 470 as well. And what do I got? 570 kilo ohms. Yeah, so that's 100 kilo ohms off. So I'm going to be replacing some of these carbon composite resistors. I'm actually going to swap out these here. So, you know, this was a resistor kit I got off of Amazon. Well, how do you say that's a German name there? Alkanine, or you know, yeah, popular Bojack resistors, which I'm perfectly okay with putting those somewhere up here, right? Say here or there. I'm perfectly okay with, you know, putting Amazon resistors up there, but I really don't want to have them here. I'd rather have a more trusted, verifiable resistor bought from a trustworthy company like Mauser. So what I am going to do is I am going to take out these back out, because, you know, they were upwards of, you know, well over 200 degrees Fahrenheit. That one as well. And I'm going to at least replace the let's see, the 1K I'm going to replace with a wire round resistor. I believe, don't quote me on this, I think your wire rounds can, you know, they can operate pretty well up to temps of 500 degrees Celsius. So what is this? The 39 ohm 2 watts in here. I'm going to replace it with a wire round resistor as well. Wait a second, what is this? Oh, yeah, 39 ohm. Yeah, it's a wire round resistor. I'm going to replace it with one of those as well. And then the 22 ohm, I'm going to replace with a Vichy metal film resistor, which I think would be good up to 200 degrees Celsius. Again, we were seeing 200 and something degrees Fahrenheit on our thermal imager. But I want to put more trustworthy components just in here in the power supply section. And the reason being is, you know, some people swear on, you know, carbon resistors with these carbon composite resistors with these older radios and stuff like that. But I'm just simply not one of those guys. As a matter of fact, I can tell you, I was at a location that was using resistor as such in a heatsink regulator on a UHF transmitter. Basically, the regulator takes, you know, it keeps our regulated voltage regulated and helps develop other voltages inside of a radio. But I noticed that when I was there in 2011, I think is when I left that place. I was working on the radio, and you know, it kind of looked like the resistor was, you know, kind of burned up like this one does, and the other two that I already swapped out. But the value was perfectly fine, and I said, well, you know, I was a lot younger then. I said, I'll just leave it the way it is. Well, fast forward like 7 years, and I'm back at the same location, and that radio is shelved because you could buy components, but you can't get actual modules. Like, depending on your type of job, you might not be allowed to replace components and something. You might have to rely on supply chain and the actual LRUs or line replaceable units, and you might not have permission to actually go in and replace components. So the people shelved that radio because it's just no worky. And I got there and I pulled it off, and sure enough, same part, and it wasn't operating because the resistor had completely disintegrated. It crumbled, falling apart. It was basically one solid wire from one end to the other. So I am not the guy who swears by carbon composite resistors. I think aesthetically they're great to keep if they're within their tolerance inside of old equipment. I am less hesitant of changing aesthetics when it comes to developing voltages from your mains. These right here definitely need to get replaced, and they just don't last as long as modern resistors, as your wire round and your metal what am I thinking, metal film or thin film or thick film resistors do. They don't have the same, for one, you don't get as great a tolerance with them. And then as far as their ability to withstand varying degrees in temperature, they just, it's not as good. But like I said, I mean, if they're within their tolerance, then and they don't look baked, I don't see why not to leave them in. But when they're out, you need just go ahead and take them out. And if they're not too bad and they're within tolerance, yeah, sure, maybe leave them in. But to me, I mean, I want to make this a lasting product, right? I want this to continue to carry on for many years into the future. So, I'll put some of these half-watt bow jacks in certain areas, but I'm going to go with a name brand source like Vishay or whatever I can get from Mauser and get those replaced. So hopefully that gets rid of the oscillating I'm hearing while tuning through the radio coming out of the speaker. It's kind of like a high frequency oscillation that's occurring. Depending on how we're tuned, and maybe that will resolve it. Anyways, I'm gonna get this on the bench. We'll start getting some things swapped out. Oh, and got myself a bit of merch here. Vince, if you watch, hey, got myself a little bit of your merch. Got my tea bag currently steeping in here. Water I warmed up in the microwave because I'm an uncultured swine from America. But hey, it's nice coffee. Coffee or tea mug. I like it. It's pretty nice. Good design. So, thumbs up to that. components changed out, especially those near the oscillator coil. Wouldn't be surprised if this thing needs to be completely realigned again. But engaging squint factor and contact.
Yeah, absolutely. It's going to start with coming off 2 tough losses. They're going to have to rebound and come out with a win against that tough sophomore SaberCat team.
No doubt about it. Well, hey, tell you what, let's take another quick timeout and we will come back with more post-game coverage.
Still got that kind of high-pitched whistling sound, but
You can always count on Horn Equipment. They offer the best.
personally I think it sounds a bit better.
Complete remanufacturing facility.
If you're dreaming of a new home, call the right place and check out Vintage Custom Homes. Vintage will tend to...
I'm gonna let it run for a little bit and check the temps of the resistors on the bottom near our rectifier. See how they look. But yeah, once I get into this 50L6 GT, I'll run through an entire alignment again. And then all that's left is really getting the case polished up and put back together. Here goes the remnants of those old bushings. They just crumble. Glad I replaced those as well. Little bushing kit I found on Amazon. Like super brittle, like they got incredibly hard. It's crazy what happens to a radio over how many years? 1948? Somebody do that math.
Part Asian, part black.
Got in some 50L6 GT tubes. Took out the 35.
So she's I'm sorry, she's not all that in the bag of chips. That's
Wanted to show y'all something because I was taking our readings incorrectly when I had that 26 volts earlier. Had my negative lead going to an external ground positive lead to pin 2 or 7. But you're supposed to make your measurement with respect to your B negative line. It's going to be maybe a bit hard for me to demonstrate this, but let's see if I can set something up.
Politics comes in.
And got it's kind of precariously sitting here, but
put yourself in a position where
let's try to do
you
it.
guys have now made it so you can't even make a change, even if it's for the right reason, because identity politics.
1,
And that hurts us
pin
all.
2,
Especially if they were to
85 volts AC. That's
I
good.
don't think he's running, and
check
I'm
pin
telling you,
7.
there's a guy in California that is not going to let
There we
identity
go.
politics and his
34 and a half,
header away.
35, whatever you want to call it, volts AC.
To be the most beautiful president we've ever had.
36 on the diagram, but let's get an alignment done.
What goes on
Okay, alignment time. And the first thing we're going to start off with is our IF alignment, our 455 kilohertz alignment through both of our tunable IF cans here, if I can call them that. Now, there are actually two adjustments in each can. There's a top capacitive adjustment. You need a special alignment tool such as this one right here. There you go. The first adjustment is going to be at the top, and then if you allow this to kind of fall through that top adjustment, you can reach the second adjustment down the bottom. These are both basically tunable capacitors, and I'll throw them up on a diagram here in a bit and try to highlight them for you. But how we're going to do this adjustment is right now I have my dial fully counterclockwise. From my signal generator, I have a alligator clips going to the output of it, attached to a loop of wire that I'm throwing underneath and in the center of here. And then because I will still be able to get some reception, external reception, I'm going to try and use this cardboard box that I lined with aluminum foil as somewhat of a Faraday cage that I'll lay over top in hopes to block out any interference. How well it's going to work, I don't know. It's not a true Faraday cage, but hopefully it can keep some of any radio stations there close by out while we do this alignment. Alright, let me bring up the SIGGEN. Oh no, that's the oscope. Signal generator. I have it set to 455 kilohertz, an amplitude of 0.08 volts peak to peak. Modulation is going to be at 1000 hertz and a depth of 90%. Okay, and I also have my oscilloscope attached to both wires running to a positive lead to this side over here, our ground lead to this side, but both sides of our coil for our speaker. And then of course the oscilloscope itself set to 2 volts per division. That is our vertical scale, and 250 microseconds on our horizontal scale. Now when I do this IF alignment, I'm going to have to primarily do this by ear. First off, because we probably won't see that 1 kHz tone that we're modulating through show up on the oscope. Let me get this turned on, and hopefully I can demonstrate what I'm telling you. Okay, well, you can actually hear it pretty good. So we're going to bump down the amplitude of our signal. Let's take it down to 0.008. And I can just barely make it out there. And as you can see, you really can't see anything up on the oscope, but from the speaker I can just barely make out that 1 kHz tone. So I'm going to adjust this starting with top 1, bottom 2, top 3, bottom 4, and go back and forth till I can hear that 1 kHz tone at the highest amplitude as it's showing on the O-scope. Right now I'm using my ears because it's just not going to register on the O-scope yet. I'm actually having a bit of trouble bringing it in, so I'm going to bump our power up just a smidge. Alright, now that I've got it closer, might be a good time to drop it down again. Our SIGGEN power, that is. I can still hear it. Let's drop it down a little bit more. Alright, I think that's going to do it for that alignment. We pretty much peaked up on there. Now we have to move on to our next alignments. Okay, for the next alignment I need to do, see, this was A1, A2, A3, A4. I need to do A5 at the antenna. That's this guy right here. Let's swap out my tuning one. So the instructions say to set the SIGGEN to 1600 kilocycles, and to set your dial to 1600 kilocycles as well. And again, we're looking for, let me turn this down. Again, we're looking for a peak voltage on our oscilloscope. Okay, and so now the next thing we're going to do is set the SIGGEN for a frequency of 1400 kilocycles or kilohertz, and then adjust this, our tuner, until we get max amplitude on the O-scope, and then adjust A6 for max amplitude. So we get this to max amplitude, and then we make our adjustment here. So let me set the SIGGEN for 1400 kilohertz. Enter. Still going to modulate it at a 1 kHz tone. And I'll be turning back up the volume and doing this over again. Those of you that needed to see the setup, there it goes from SIGGEN to antenna down here. Loop obviously underneath the antenna. But I've got this back on 1600 kilocycles with a 500 hertz tone modulating in at 80%. You can hear it. Don't have the O-scope hooked up anymore, but I did want to answer that question from video 1, where does our oscillator, does it shift up or shift down, you know, on the frequency it generates corresponding to what frequency is at the tuner. And so I took my 1 megohm O-scope probe, I hooked it up to the front of my frequency counter, and yeah, we're gonna check that out real quick, see what answer we can get. Now, ideally, you'd want to hook this up in a way to where the device does not feel, the electronics do not feel that you're testing something. But I'm only doing this for poops and laughter. And yeah, I mean, it's loading down the frequency a little bit, our signal. But yeah, if we're at 1600 and say 455 in addition, that would be what, 2055? So yeah, it's definitely because I'm loading down the signal. I have to adjust the tuner again to get it to where I can kind of hear it. But yeah, I suppose if it was just attached in a way where it wasn't filling or sensing the device under test, this wasn't loading it down, then you would see that 2055 up there instead of it being slightly lower. But there goes the answer to that question. So the oscillator puts out 2055. Your incoming frequency is 1600. They're heterodyne together, some difference in two originals. And then, of course, the difference would be 455 kilohertz or 455 kilocycles, whichever you want to call it. But that's the answer. So there you go.
Let's get to the phones. You're on the Sports Animal. Go ahead, please.
Either a better time of day.
Hey, Jim, what's going on? What's happening, man? Yeah,
or the alignments allow me to pick up a few more stations.
Okay, and let me tell you something, dude. You better explain yourself right or you're done. I'm just letting you know because we're...
I almost get that one. kind of getting something there.
But I'm trying to understand how it is that people have these bizarre positions. Dick Blumenthal in Connecticut. This weekend I heard protesters chanting.
And there. Something kind of there.
And I would not want to change that if I were you, given that we're a Second Amendment state.
Florida Attorney General Ashley Moody.
There goes that station that comes in really well. So I'm picking up a lot more stations than I was previously. Either due to the time of day, or the alignment actually did us some good, gave us back quite a bit of sensitivity, and you know, yay. That 50L6 GT seems to be drawing a bit less current from the power supply. Now these wire wound transistors being up in 200 and something degrees Fahrenheit, that's not necessarily a bad thing, because you expect them to dissipate heat a lot better than those carbon resistors were doing. So that what you're seeing is that heat dissipation. But these have definitely gone down a bit as far as their temp. So my assumption is that we were drawing more current with that 35L6 GT in versus the 50L6 GT. At least that's my assumption. Okay, so overall I'm pretty happy with how this radio's turned out. It sounds great. I've kept it plugged in and running for a while, and it's running really well. So that's going to be it for this portion. And coming up on the last segment, we're going to take care of everything concerning the chassis and get it put back together and looking real nice. Thank you for watching. If you enjoyed this video, and if it helps you along your journey restoring radios or anything, again, I'm a novice to AA5s, but I feel like I've come to a bit of a greater understanding in how they operate and how to align them. I don't know. You leave some comments down in the comment section and tell me what you think. Again, thank you for watching. Thank you for your time. Please consider subscribing and liking the video. If you have something that you want repaired or restoration, my business information's in the link to the Google site down in the description. Or if you just want to donate to the channel, there's a PayPal link as well. Appreciate your time. Take care. Goodbye.
Bart?